Okay, good afternoon, everybody. So today is February 25th, right? So as usual, let us see our schedule. So according to our schedule, so this week we will complete sorting and searching algorithms. Okay, so in my previous lecture, I discussed searching algorithms. Okay, and I went through a live program. Okay, but okay, I was trying to upload the last lecture video, but it was taking time. So hopefully it will be downloaded soon, and then after my lecture today, I will upload both. Okay, so it's called linear search algorithm. Okay, so in a previous lecture we discussed linear search algorithm, searching algorithm.
Professor, can you share your screen?
Oh, okay. Only there are 6 people here in 7, right? Oh, you're the 7th one. There are only 7 people here in face-to-face lecture. Okay. So which one you feel better, face-to-face or online or from home? If
Online.
Huh? Online?
Yes.
Okay. So, but if you feel in trouble, then please let me know. You can hear me clearly, right?
Yes.
Okay. So in our last lecture, we were discussing searching algorithm, right? Searching is a process that we find a specific element from a list and we check whether the element exists in the list or does not exist. Okay, so there are different kind of searching for different result. For instance, here this is a list. Okay, we call an array, right? So far, everybody we know how to declare an array. In my previous lecture, we discussed how to declare an array. So in this array or list, in this list, these are the elements. So elements I selected randomly. We don't need to be any specific element. For instance, we will check whether an element, for instance, 7, exists in this list or not. So what is the process? The naive process, an easier is process that apparently easiest process that we will check for all of the elements from starting one end, either from the left or from the right end, and we'll check whether an element is 7 or not, right? So for visually for a small data set, it is easy to find it, right? And then for this small data set, visually you can see that 7 exists 3 times. Okay, the search result, it can tell us that yes, 7 exists. If it exists at least one time, that 7 exists. And more elaborately, we can find how many times it exists. Then if it does not exist, then it exists 0 times, right? If it does not exist, then that means it exists 0 times. Okay. So the way checking from one end to go all the way other end. Okay, this is called linear search or serial search. Serially going one by one. Okay, we need to check every element. So we know that how can we get every element by using index of an array, right? Starting from the first index with 0 and the last index value will be n-1, where n is the size of the array. Okay, so okay, so in my last lecture I discussed same program with Java and C# also, and this is C++. Java and C#, they have and modern programming languages, they have a method or attribute, built-in method or attribute that can be used easily to find the length or size of the array. But C++ does not have. Okay, Okay, I don't know if it has right now. It may be added. So, but we can find the size. How can we find the size? There is a size of method in C++. So size of method, it takes the array as an argument. We will discuss method in our next lecture, okay? And then divided by size of int. The size of int is 4, right? So that means with the size of the total, my data is 1, 2, 3, 4, 5, 6, 7, 8. There are 8 elements, right? Each of these integer type. So this is why I'm dividing by integer. Total will be 8 times 4, 32 byte memory space this array will take, and we are dividing by 4. That means we are getting 8. There are 8 elements, right? So then what do we need in order to do search operation? Initially we will think that our element does not exist. Then we can use a variable that is called counter variable, or count. We can say counter initially 0. Okay, we can do it in 2 ways, using integer count variable or using boolean flag. It's a flag. Okay, so what we will do, so everybody understand now for loop, right? How do we use for loop? Starting from 0 index and less than size. It must be less than. You cannot say greater or less or equal to. If you say less or equal to, you must use -1 here. So here is a trade-off. If you use equal sign, then you must use -1. Same thing, right? See, in integer value -1. Instead of giving -1, I can say less than. And then what we are doing is using if every element, checking every element, my data I equal to my target value. My target value equal to 7. Then if it is matching, then we say flag equal to true. That means initially flag was false, then we found it, right? We got it. Or we can say count equal to count plus 1. That means initially count was 0, but if I find it, then count will be increased. So this is the code actually. This is the code, like these few lines. Actual codes. Oh, sorry. These are the few lines. It's not difficult. Has anyone any question about this? How it works? You will understand, right? So you understand this is a relational operator, equal. This is not equal. If you give only one equal sign, it will not work. Luckily, our compiler is showing an warning message here, right? Okay. Then once we get it, then we can use another if condition. So outside this for loop, so if flag, that means if flag equal true, then we can say my number target is found how many times, count times. Else, otherwise, that means it does not exist, right? If flag equal to false, that means it is not match. There is no match, right? And this is the way to do it. Okay, so in your test, upcoming test, in one of the tests, you will probably get a question like this. You are given an array element, okay, and you will be asked to check whether any target value exists in your array, and if it exists, how many times it exists. If it does not exist, then say, oh no, it does not exist, it is not found, right? Okay, so there is nothing to memorize from this code. You need to understand. Okay. Has anyone any questions so far? So in my last lecture, I discussed this program using Java and C# also. Okay. So if you understand C++ code, you should be understanding and other language, right? And if you understand a code in one language, then you can write it in pseudocode format, right? Now we can write it pseudocode format, right? Okay. So now let us go to our new content today, and then we will discuss okay, this is called linear search algorithm. Okay, there is another searching algorithm that is called binary search algorithm. Binary search algorithm works better if our list, if the given list is already sorted in ascending or descending order, but we may not get that way in our data. Okay, so this is called binary search algorithm. Binary search algorithm is implementation is a little bit difficult. Okay, but it is faster. Okay, how do we do a binary search algorithm? Okay, for instance, in binary search algorithm, we assume that our given data set is already sorted. If it is already sorted, for instance, 32 elements, we need only 5 search, 5 individual search to get the element or tell that the element does not exist. Because 5, why 5? Can anyone guess why it is called, why we need 5 search for 32 elements? You understand logarithm, right? You studied logarithm in high school. So if we say LZ, that means in computer science and programming, in most of the time we use LZ. That means it is equivalent to log with base 2. And natural log is called log, ln, or is called log with base e, natural e. Okay, but LG is log with base 2. Okay, so if we say LG 32, right here, 32, that means 32 over here, that means LG base 2, 2 to the power 5, 2 to the power 5 equal to 32, right? That means equal to 5 times LZ 2 with base 2. That is 1. So this part equal to 1, equal to 5 times 1 equal to 5. So for any log A with base A equal to 1. That is an universal truth. Right? So here 2 to match, so it is 1. So that means if you have if you have 4,024, right? Okay. So if you have 2048 elements in a list, Okay, so then with binary searching algorithm, it will need only this 2 to the power 11, right? Only 11 search. 2 to the power 11 equal to 2048. So it will need only 11 search, okay? But so binary search algorithm, it looks efficient, right? But one thing is that binary search algorithm is applicable only if our data is pre-sorted. So then you may ask a question. You may think that okay, no matter if I have my data, I will sort it. Then I will apply binary search algorithm. That will not be efficient because all sorting algorithms take longer time and difficult in than searching algorithm. Okay, so why I'm going to sort all of them first, right? I need to do that. So in that case, we will use another algorithm, the linear search algorithm. Okay, so the binary search algorithm, the algorithm is a little bit difficult. So let me explain. The create low, we need a low and mid 2 points. Okay, and then we need high point. Okay, and then initially found equal to false. So the concept is like this. For instance, we are given an array. Okay, so an array. We are given an array. So the first index will be 0, right? And the last index will be L minus 1, right? So initially what we can say this one as low. We can say this one as low. And this one we can say high index or highest index. You can say lowest or highest, no problem, okay? And then how can we find the middle element? We can find the mid equal to, okay, low plus high divided by 2, L plus H divided by 2. So this is an integer division, so it will give us an integer number. So that index we will use mid index. So we will use low index, mid index, and high index. Okay. So the formula is that, process is that, algorithm is that we will create a found equal to initially false and say while high less or equal to low. The concept is that we will checking the mid element or less, but we will go in, we will move from low to right. Okay, from low will be moving towards mid, and high also will be moving towards mid. So at this point he will be moving, right? So how long will we will be searching? As long as our high become equal or greater than mid, greater than low. So this cannot pass. Low cannot pass high, and high cannot pass low. Okay, so why this is why while mid high greater or equal to low, what we will do, we will find our mid index, mid equal to low plus high by 2, and then we will do a searching algorithm over here. We will see search if find, okay, less or equal to Okay, so this is target. Okay, find our target. You can say this is target. This is our target. So if my target value is less than search an array, this array name mid index less than, then what you will see, everybody give attention please. So if our element, for instance, we have element over here 2, 7, 9, 10, 12, 14, 15, 20, 23, 60, 65. Randomly I put some numbers, okay? And this number must be pre-sorted. So we know that this number are sorted, right? So for instance, we want to check for 7. So for instance, what you will show, we will find the low index 0, high index, how many numbers? 1, 2, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So low index equal to 0 and high index equal to 10. We have 11 elements, right? So the mid will be 0 plus 10 divided by 2, 5, right? The mid index will be sixth element. 0, 1, 2, 3, 4, 5, 6. So this is the sixth element. Index 5, that element is 6. So we will check for this element, right? So we will get this element with index at mid. So we got 15. Now we will check 7. Is 7 less or equal to 15? If it is yes, then what do we need there? We are confirmed that we do not need this part, right? We are confirmed that if our number, since the number are already sorted, if our number, we find that our number target value is less than our mid value, so then we don't need this part. You understand? Because it is obvious that our element exists in the left side of middle. It never goes right side. Understand this way? This is why we are getting a high equal to mid minus 1. So what we are doing, we are discarding this part. How can we discard this part? We will jump, a high will be, this one will be a high. Initially my mid was this, right? Mid was 5, then our h will be 4 at this point. You understand? That means we made our list half in one iteration. And else if is our target, so don't be misleaded. Okay, if our target equal to search, then we got it, right? If our target is equal to mid element, then we got it. Okay, you could give this one at first, this one second, no problem. Okay, else, what else? If it is not the middle element, if our target is not the middle element, if it is not the left side, then it must be in right side, right? So here, otherwise, if it is in right side, what we will do, we will jump low, we will move this low, sorry, we will move this low to the right side of middle. This is why we are saying low equal to mid plus 1. So here, if my element is in the left side, then we will move the high. If my element, we find that our element is greater than middle, then we will change low. And how long it will continue? As long as our low is less or equal to high. That means as long as our high is greater or equal to low, same thing. Okay, this is the concept of binary searching algorithm. The concept is little bit tricky at the beginning. I like you to take a piece of paper. Okay, do not jump through program yet. Okay, just trace this pseudocode. Okay, try to understand this. Once you understand the core concept, okay, then you will be able, you can see that you can write this if first, and you can bring this as else if. Even with it, there is greater or equal to sign here, you can make it less or equal to, you can say low, less or equal to high, same thing. But if you understand the concept, this is not too difficult to implement, right? Once you understand the code, so you can write code for every line, right? These are all variables, right? All variables, and you know how to use if, else if, how to use while, right? So here is while is outer while, and with while there is if, else if. Okay, has anyone any question? In your test, you will get a question. Either searching, linear searching, or binary searching. So now let us compare these two searching algorithms. Which one is better and which one is efficient? Which one is better? There's a trade-off between, right? We cannot say exactly which one is better, right? The binary search algorithm is better, but it has a limitation, right? What is the limitation of binary search algorithm? What is the restriction? Yes, tell me. Yes. Sorry? Yeah, their list must be pre-sorted, already sorted, right? If our list is not sorted, we cannot apply binary search algorithm. We can apply, but that will not be efficient, right? Okay. Now I understand. Has anyone any question about binary search algorithm? Okay, so I think I should have. Okay, so I have binary search algorithm program in C#, I have in Java, I have in C++. Okay, I'm sharing this code with you, so please practice this. Okay. One in C#, another in Java, then in C++. So all of my code is here. Okay. So they are a little bit different. You see, I have binary multiple versions. Okay, so I have binary search 1, that is one version. That I have binary search 2, that is another version. Okay, so you can implement anyone, whichever you like. Okay. I have two different versions in the program. Okay, what I like you, please get you, you are getting code, right? Actual code. But do not memorize it. Do not copy and paste it. If you want to learn this, please type in your it, okay? Follow, you can follow this, okay? Type in. Whenever you type in some code, you will do some mistakes, right? Once you do mistake, you will get error message, and then when you get some error message, try to understand what is the error is coming from, the line number, right? You will check the line number. So, and then you will see what is the error is coming from. For instance, if I do like this, and if I want to run my program, it will give an error message, and the error message will see that main.java colon 55. The error number either will be on 55 or above 55. It must not go down to 55. So here on line number 55, then it is also, if it is giving an arrow, up arrow, showing that probably the problem is here in this line. Sometimes compiler exactly can give you error message, but sometimes it cannot. It will give you hints in general. So you say cannot find symbol system.out.println. So what did I miss here? What is my mistake here?
The T missing?
Yes, so I missed T. Okay. And then I fix it. And then whenever you get like this kind of error one time, okay, so do not be afraid, but try to understand, read the error message, okay? Almost if you understand a few, like 20, maximum 30 error message, then you will get 80% error messages. You will see that almost all of your error will come from this. Okay, another thing is that okay, try it. Okay, so I have to move for the next one. Okay, has anyone any question about searching algorithms, especially the binary search algorithm? We have code written in C++, Java. This code is called code snippet, part of a program. It's not a complete program, right? We need to put this code in the main method, right? You understand, right? Okay. Now let us come to sorting algorithms. Okay, what is meant by sorting? So sorting is a process of rearranging our elements in a specific order, maybe from smallest to highest or highest to smallest. Okay. So if our list is pretty short, then sorting algorithm will be an easier, right? So if I get 5, 2, 7, 9, we have only 4 numbers, right? And if we want to sort this in ascending order, it's easy. Just 2 will come here, then 5, 7, and 9. It's easy, right? But so we see that 2 is we need to move over here, okay? So apparently visually it is easy. But in programming concept, what we need to do, we need to check every element one by one, right? We need to check the first element with the second element. If the first element is greater than second element, we need to make a swap. We need to swap. And then we need to check this element 5 over the next element. If needed swapping, we need to swap. We need to exchange. And go on. So we will need to go all the way in. Okay. But since there was only one item was disorder here, it was easy. But think about if there are more elements and more disorder elements, then we need more and more time, right? So all sorting algorithms take more time than searching algorithm, because in sorting process you need to do searching. So searching is included within sorting. You need to apply the concept of searching within sorting. So there are a number of sorting algorithms. Okay, I know about 8 to 10 sorting algorithms. Okay, so we will cover a few only a few here in this course. So first one is called bubble sort algorithm. You can see this video. Okay, or I have my own videos I can share with you. So bubble sort is the process. For instance, you see that. For instance, we are given. This is our initial. This is our initial array. Initial. Array. It's called given or initial arrays. Okay. So this is disorder, right? So what we want to do, we want to sort it in descending order. Descending means descending. You know how we remember descending? So D, when you need to write D, you need to, in uppercase D, you need to start with a large bar, and then you see that D is become, this side becomes smaller and smaller, right? So in descending means your highest element will be in the left, and then it will be ended with lowest element. And ascending, we start with A. So ascending, so you see A start with a small cap and then it expand larger and larger. So that means 1, 2, 3, 4. This is ascending order. Smallest is come first. And then descending is a 5, 4, 3, 2, 1. Okay, so in the bubble sort algorithm, what we do, so how many numbers are here? 1, 2, 3, 4, 5, 6, 7. So there are 7 numbers. So we need 7 minus 1. That means 7 minus 1 equal to 6 comparisons. 7 n minus 1 comparison. Okay, n minus 1 comparison. All I need. N is the number of elements. So how do we compare that? We will take a bubble. Okay, bubble, that means is a bubble, like it's a bubble, right? So this is a bubble. You know, this is bubble. So in the bubble, we will consider only the edges. Okay. So on if this side 8 and this side 9. Okay, so then we will compare whether 8 is less than 9. Yes, right? So then we will exchange. So the exchange will be 9 will come here and 8 will go here. So you see that 9 is coming here and 8 is coming here. And then what we will do, so initially, this was initially, then we are, so we are checking this bubble, and then we need an exchange swap over here. And then what we'll do, we will move the bubble from left to right, and every time we will compare the two elements in the left side on the bubble and right side, not, and we will keep the bubble with same size. Okay, so bubble will be same size always. So first one 8 and 9 will be compared, and then 8 and 9 is, since 8 and 9, 8 is less than 9, so 9 will come here, and then after that this 9 and 3 will be compared, and then it will be, these will be compared, and again these will be compared, and these two. You see that our same bubble is moving from starting from, actually we could give one more line over here. So bubble is coming from, actually I could give one more line over here. Input, same input is 8, 9, 3, 1, 4, 2, 7. This is my original input. So we need 6 bubbles. So how many bubbles we got over here? 6, right? 1, 2, 3, 4, 5, 6. So that means 6 comparison. So with 6 comparison, at the end of 6 comparison, what we will get? We will get one element sorted in position. Okay, maybe we are doing an ascending order here. So we will get 9 in position. We will get one element in position. Okay. So the next iteration, how many elements we need to check? N minus 1 element, right? So next iteration, in the next time, 9 is already sorted, so we don't need to include 9 again. So we need to sort the remaining part. Okay, so the first time there are 7 elements that took 6 comparison, and the second time, second phase, there will be 6 elements, so it will need 5 iterations, n minus 1 iteration. And the third time there will be 1, 2, 3, 4, 5 elements, so we need 4 looping bubble. Okay, and then next time we need 3, and the next time we need 2, and the last one 1. Okay, so then if we add up this 1 plus 2 plus 3 plus 4 plus 6, 1 plus 2 plus 6. So what is the value of this one? What is the value of 1 plus 2 plus up to n equal to n into n plus 1, right? 1 divided by 2, right? Sum of the series, right? So here n equal to 7 over here. So here 6 plus 5, 11 plus 4, 15 plus 3, 18 plus 2, 20 plus 1, 21, right? So equal to 21. So here 6. Okay, so n into n minus 1. 7 times 6 divided by 2 equal to 21. Okay. So that means we need total 21 iterations. in order to do this. Okay, so the first after 6 first iteration, okay, it will be 9 in position, then we got this. Okay, in the second time we have 9 already inserted, and then we will go up to this one. So the after second iteration we will get another 11 in position, and it will take 5 iterations. 5, there are 6 elements. Why do 5? 1 2 3 4 5 6 elements, so always n minus 1 comparisons. And after that, in third phase we need 4 iterations. In fourth phase we need 3 iterations, and in fifth phase we need 2 iteration comparisons, and the last phase we need 1 comparison, and total comparison will be 6 plus 5 plus this good. So here sorry. So here equal to 6 times 6 15 21 plus 1. Okay, the last element, if you say n over here, so then it will come here by 2. So then 6 times 7 divided by 2, 21. So we will need total 21 iterations. Okay, so later you will learn, since that, so in order to implement this we need 2 for loops. One is inner for loop and another is outer for loop. Okay, so when you see that bubble sort code is here, I equal to 0 to I less than n minus 1. Okay, what is the n over here? N is the size of the array, and I plus plus, and j will be here. Actually j equal to 0 to j less than, actually j minus 1 is actually like this, minus I, j minus n minus 1 minus I. So you understand this way better. And j plus plus, we will check if array j is greater than array j plus 1, then we will swap. Here is swapping. Okay, swapping is another process that exchanging 2 elements is position. Okay, so let us do a quick activity. Okay, you will take 2 items on your 2 hands, any item in your phone or something, anything. Use your both hands. Okay, put 2 items, either phone or a key. Okay, everybody, are you ready? So people on the online, okay, please join with me. Okay, take 2 items, any 2 items. It can be a phone or key or pen or pencil. Okay, 2 items. Okay, what your task you need to do? You need to exchange, or that you have one item on the left hand, right, and the item on the right hand. You need to put the item that is currently in your left hand, you need to put that on your right hand. You need to bring that on your right hand, and the item that is on your right hand, you need to put it in your left hand. Do that. Can you please do that? Okay, you have done quickly, right? Okay, but there is a condition. There's some conditions. Okay, first of all, not at any certain moment, not for any certain moment, for any millisecond, even millisecond, you cannot hold 2 items in a single hand. That is the one condition. You cannot hold 2. No, okay, that one condition. Second condition is that Only three conditions I have. Okay, you cannot put them. You cannot put them anywhere on the table. Any item you cannot put on table or something anywhere. You cannot fly them. You cannot throw them on the air. Some people know ping pong, right? They play ping pong. They use multiple balls and then they throw on the air and they solve, right? You cannot do that. This is not a ping pong. Then with the three conditions, what are the conditions? For no time, you can hold two items on a single hand. You cannot throw them on the air. You cannot put on any table. Now, can you do that? Try now. Try yourself. Can you solve, for instance? Can you do that? Okay, you will get $1 million. Okay, you will yes. Huh? No, that is the one. You cannot hold two items in both hand or single. One hand, one item. It's not doable, right? If you can do it, you will be famous than Einstein or Bill Gates. Anywhere. I said, oh, not on table. I said anywhere. Anywhere. You cannot hold it. And you put it anywhere. So you can do it, right? If you put anywhere, right? If you in the lab or in the table or a chair, if you put somewhere on ground, then you can do it, right? Otherwise, we cannot do it. So what do we need? We need another position, right? That is your lap or your table or chair will be another position, right? That we can hold, we can put one item, either of the items, right? So using that is will be called a temporary location. Because whenever we remember that whenever we use variable, right? We use memory location. Remember that variable are stored in memory, right? So memory location holds only one item at a time. If we put another item, the previous item will be gone, overlapping, overriding. The previous one will be deleted. Okay. So then what do we need? We need a temporary another position, temporary memory location. Okay, of same type data type. Then this is my temp variable. This is why we need to use for swapping. We need to use a third variable. Without using this third variable, we cannot do it. Nobody can do it. So this temp, at this temp, what we will do, we will put any value. For instance, the first value. Then in the first value will be replaced by the second value. For instance, what you do? So let us do that complete activity. Okay. The put whatever you have on your left hand, whatever you have on your left hand, put that on a table. Okay. Now your left hand is empty, right? In computer memory, it will not be empty. It will have also. Now whatever. Okay. Don't throw it. Don't break your phone. Okay. So you got it, right? So what did you do? You put your item that was on your left hand on a table. Then your left hand is empty. Then move the item that is your right hand to left hand. Okay. Now your right hand is empty, right? Now bring the item that was on your table to your right hand. Now you got it, right? Now they are exchanged, right? So this is the process over here. So these three lines, exactly what I do have done these activities, but for some people this seems to be critical, confusing. Okay, so the concept is that you understand. Maybe your left hand, this is your left hand, and this is your right hand item. This is left hand item, this is right hand item. Okay, so what we will do, we will use a temporary variable and put the left hand item on temp, and then put the right hand item. So we are using equal sign, right? The assignment operator. It puts the right value to the left side, so that we are making array j equal to array j plus 1. The right side element will come to array j. So at this point, both at this after this operation, both item will be same, right? But we have another copy here on temp position. So that copy we will put on the right side, right element. So that copy temp was the left element. So the right element got the value of that element. This is called swapping. Has anyone any question about swapping? It's called swap or exchange. Everybody's okay? You understand? I just do so. Okay, only 3 lines, but it is confusing for many people. But if you do this activity, if you don't understand, then do this activity a few more times, okay? Few more times, do this activity, okay? Put left side one on the table, move the right side, the left side, and you get the item on the table. Then you got it. Okay? So in the bubble sort, we need to do this swapping how many times? We will not count how many times anymore. So we counted to only 1 times, right? For 7 elements. So the process is that we have 2 for loops, right? So one is called outer for loop and inner for loop. So whenever you say inner for loop and outer for loop, so you will learn this whenever you take advanced courses, algorithmic analysis. So you are in this course, you are learning, you are getting an idea about algorithm, right? What is an algorithm? Is step-by-step process to solve a problem, right? So an algorithm can be an efficient algorithm, it can be a good algorithm, it can be a bad algorithm. For instance, I want to go to downtown from here. If I ask you way, okay, I can drive 100 miles to go to downtown from here, right? I can detour many way, and then I can drive 100 miles to go to downtown, right? I can drive 200 miles, 500 miles, 700 miles. I can go Dallas from here, Dallas, Texas, not this Dallas, Georgia, okay? And then I can come back to downtown in a different route, right? So that is not a good algorithm though, but this is a way to solve the problem, right? So not all algorithm will be efficient, but we will search for efficient algorithm, and we will use the algorithm that is as efficient as possible. So then what you will do, and so we need to understand how to measure the efficiency of an algorithm. How to analyze algorithm. In order to do that, you need to analyze algorithm. That means you need to analyze to see, is this a good process? This is a good process? Is this the best way? So if you take your, like when you go 4th year, maybe I'm teaching on the course algorithmic analysis. Then when you take that course, then you will assess your, analyze your algorithm. You will learn how to analyze algorithm. But in large things short, I can tell you that, so this algorithm, it has 2 for loops. So it says big O of n squared. So n means number of elements. Since there are 2 overlapping for loops, so looping, so we need big N squared. So that means efficiently we have, if n equal to 7, that means it can maximally take 7 to the power 2 equal to 49 iterations. It will not take more than 49, but it may take up to that. Okay, now what is your question? If my algorithm is inefficient, it will take long time to execute the program. So for the small program we are discussing in this class lecture, right? So if your algorithm is is inefficient, still it will take a few more millisecond time. You will not realize that, right? But think about that if you are designing an algorithm to sort all people population in the USA or all population in the world, and how much time it will take if your algorithm is not efficient? It will take more time, right? So then, are you okay with it? Yeah. Okay, you understand? Okay. So this is the bubble sort algorithm. Okay, so bubble sort inside it does a swapping algorithm. So everybody understand swapping or exchanging? Okay, so this is called bubble sort algorithm. So we have code. Okay, okay. For there is another version of bubble sort algorithm. Some people say it is called exchange sort algorithm, but some people say it is not exchange. It is another version of bubble sort algorithm. Okay, so that what it does, the exchange sort algorithm, it does. Okay, what we did for the bubble sort algorithm, we took a bubble, right? We took a bubble and we keep the bubble size same. We make the bubble size same bubble, and we move the bubble from left to right. But in the exchange sort algorithm, we will keep the bubble same position, but we will make the bubble larger. First bubble will be this, second bubble will be this, third bubble will be this. So this is called exchange sort. First bubble will be this, for instance 4 and 8 will be here, and second bubble since okay, so we are making an ascending order over here. So second bubble will be larger. Okay, 4 is here, 8, and then we have 2. We have 2 here. So we will check only the elements that are on the edges of the bubble, not inside. So we will not compare 8 here, right? We will compare 4 and 2. Only the elements on the bubble edge, not inside. Okay, so then since 2 is less than 4, so then what will happen? Our at this position, 8 will be in its own position. Okay, I'm sorry, I'm getting so 2 will be here and 4 will be here. So you see that one. 2 will be here, then 8 is inside, and then 4 will be here. Okay, then we will make the bubble again larger. So then we have 1 over here, and then we will compare this 2 with this 1. We will not compare the elements that are in the middle because we are considering only the elements that are on the edges, on the edge of the bubble, okay? On the border line, not inside. So then we will compare these two with 1. Since 1 is less than 2, so then after this iteration, 1 will be coming here. So 1 will come over here, 2 will go here, and 8 and 4 will be in place. So after first iteration, we will get this. This is after first iteration, we will get this. So after first iteration, what we will get? We will get 1 element in position. Since we are doing ascending order, we will get the left element in position. Then what next? Next iteration, we will consider only these 3 elements, remaining elements. The element that is already in position, we will not consider that again. How can we can disregard this? Just we will increase the index. We will not consider the first index. We will go index equal to next index. Increase index by 1. Then we will get this element. And then after this process, we will get another element in position. 2 will be in position, and so on. Okay, so in your test, if you are given a question, you will get a question from one of the sorting algorithms. Okay, so far we discussed bubble sort and extend sort. Okay, so you will not need to draw, but you will be you may be asked to show all phases. For instance, here you may be asked to show, for instance, this one, you may be asked to show all internal iterations. That means this, or you may be shortcut asked to say write only the latest iteration, final position after first iteration, first phase. So this is the final after first phase. Okay, this is the final after first phase. So you see that what we are getting over here after final. Let us compare this initial with this final. What are the difference? Let us compare this. So initially, this is bubble sort. I came back to bubble sort. Okay, bubble sort. Bubble size is same. Extend sort, we are making bubble larger. So here you see that. So in the first initial elements are 8, 9, 3, 1, 4, 2, 7. We have comma in between. Okay, I'm not giving comma. Okay, so after bubble sort with the first phase, so in the first phase, where do we start from? Where did we start from? A bubble from this here, right? So only these two elements will be here. So these two elements, whatever is greater, so you are doing descending order over here. So this one, this one, if we do for descending order. So this one is greater, right? So this will be, oh sorry, for ascending, this is ascending order. For ascending order, okay, so no matter the first element, so we know that for ascending order, the last element is the largest, right? So between these two, what is the largest? 9, right? 9 go all the way end, and 8 will stay over here. Okay, so since 9 is gone over here, so we need to consider 3, 1, 4, 2, 7. So 8, 3, 1, 4, 2, 7, and this 9. You understand how did I do quickly? Since there we are comparing these two elements, so for ascending order, right? For ascending order, the greater one will go last. So then move this to the last, and then this one, lowest one, is first over here, and the middle element will be middle. So this entire part will come
Oh, I
here.
need to go get some stuff.
Okay, and then for descending order, what will do? What will be done? So descending order, the highest one will come here, right? Okay, the highest one will come here, right? And then lowest one, this among these two, lowest of these two, this one will go all the way end, and the remaining element will come here. 3, 1, 4, 2, 7. So then this element is sorted here, okay, for descending, and for ascending this element is sorted, okay. So if you read the question, if you are asked to write only the final position after first phase, then you don't need to write the internal phases, internal values, okay. Only the first and last. If you understand this technique, you will be able to do that. Do some practice, okay. Okay, give me a few more minutes, please. Let me finish it. Give me 4 more minutes, please. Okay. There are other algorithms, okay. It's called selection sort algorithm, insertion sort algorithm, okay, merge sort algorithm, quick sort algorithm, bucket sort, radix sort, okay. I know you will learn this when you take your algorithm course or your data structure course. You will learn this, okay. So there are some comparisons. You see the bubble sort algorithm, okay. And then insertions, okay, so we have insertion sort algorithm, okay. So bubble sort and selection sort, this algorithm takes big O n squared, okay, that I showed you, okay. And then another algorithm is called insertion sort algorithm. So insertion sort algorithm people use frequently. For small data set, we use insertion sort algorithm frequently, okay. So this is the insertion sort algorithm, okay. I don't have time today, but you please spend some time to see if you understand insertion sort algorithm. I will spend some time in our next lecture for insertion sort algorithm, okay. And one thing is that there is a built-in array, and modern programming languages, most of the modern programming languages have a sort method, built-in sort method that we can use, but in your test you will not be allowed to use built-in sort method. You are asked to write your own sorting method, okay. Just we can use arrays.sort. You will learn object-oriented programming when, then you will learn how to use this, okay. But okay, C++ does not have this, but C++ it has, it's called vector, that is called built-in array, okay. We are not discussing in depth here, okay. And give me 1 more second, I can give you some code about insertion sort. Okay, bubble sort, right? Okay, bubble. There are many sorting algorithms here. Insertion, counting. Okay, I don't have time today, but in our next lecture we will discuss with some live program. Okay. Okay. Has anyone any question? Okay. How was your test? Good. Okay. Yes. A question. Actually, we need 2 more weeks. We have expected to complete it in 2 weeks.